What's up everybody, welcome on this new tutorial. Today I'll explain how you can build and run a Docker container for your machine learning model. Before diving into any technical aspects, why would you bother creating a Docker image for your model? The main benefit of doing that is because it can make the deployment process easier. Once you have your Docker container, it can run on any cloud platform like AWS, Azure, and Google platform. So to achieve this goal, we will proceed step by step. First, create your model and also create a Flask application for that model. And finally, create a Docker container to deploy that model on a Docker registry. If you're ready, let's get started. And this is what the final application looks like. The user will be able to provide a text and the model will make the prediction based on that text to identify if the underlying sentiment is positive or negative. In my previous video, I have already explained how to create the machine learning model that we are going to use in this tutorial, and I will also provide the link in the description below so that you can watch the whole video how to create that model. But the same code is being used here. We have different files, the preprocessed data file and the train.py file. The first file contains a couple of functions about the preprocessing phase of the dataset that will be used to create the machine learning model. And we have the read data, which is going to read the data from a specific path provided. And the preprocessed data is going to compute some preprocessing in order to rename the columns of the data to make them into the correct format. And finally, we have the clean data function, which is going to run a lot of preprocessing steps like removing punctuation, convert to lowercase, and so on. And finally, remove words that are less than 2 letters. And in the main entry point, now we can run all these functions, the previous functions, with the variable here. And running this function, running this file, Python preprocess data. First of all, in the data folder, we have only the spam data, which is the original data. And running this file is going to generate the clean data CSV that we need to train the model. And here we have the clean data that is generated. And with that, we can finally proceed with the training of the machine learning model. First of all, what we do is to load that file that we have generated from the preprocessing. And now the required step, like splitting the original data into training and testing, and now finally create a SVM model to train on the training set. And finally, we are going to save the model and the vector on different folder. The model folder for the machine learning model, vector folder for the vector that has been created during the training of the model. This has a couple of benefits. The first one is that when we generate the data vectorizer, we're not going to generate that vector every time that we are trying to make a specific prediction. And also that vector is going to be deployed on the Docker container that we will use along with the SVM joblib file as well. And this is serialized here using the joblib library. If you check also the model, and yeah, we have the model and vectors. So how to create a vectors folder. So let's create that vectors folder. These folders are empty, model and vectors, and running this train file is going to create those files. So Python train, let's clean a little bit, and Python train is going to generate those files in the respective folders. Here we have the SVM based model that has been generated here, and here also we have the vector file, which is the data vectorizer joblib. Now that we have the model ready and all the artifacts, the next step is to create a Flask application to help the user interact with that model. But before that, let's create a virtual environment to install all the dependencies. And this is going to make the deployment process easier. The syntax of doing that is python-mvenv docker venv. So the docker venv is the name of my virtual environment. You can give whatever name you want, but in this specific case, I'm giving that name. And running this is going to create this folder. And now we have to activate that virtual environment to be able to use it. So the syntax is source my docker venv bin activate, and this is going to activate the venv here. Okay, now that we have everything set up, we have the virtual environment. The next step is to install the dependencies that are required to create the Flask application. So we are going to install two libraries, Flask and joblib. So this is done using the pipenv library that we have previously installed. So we run pipenv install Flask and joblib. This is going to install the two libraries that we have. And after that, we have two files that have been created. The pip file, which contains all the dependencies that have been installed, and also the pip log file. The pip log file, you don't need to bother trying to understand what it means, you know. The next step is to move in the understanding of the process. So basically, the first 12 line is about importing the libraries and also loading the models, because to be able to run the Flask application, we need to load the required model and also the vectorizer. With that, we create a Flask application instance. Now we create the route, the default route, and also the route that triggers the prediction of the model. For the default route is going to generate the home HTML file here. We're going to explore also this HTML file, what it looks like. Once we go to the predict route, like the URL/predict, this is the predict function that is going to be called. It takes the information from the message attributes in the form. That form is in the home HTML file. And once we have this message, we preprocess that text using the vectorizer, and now we take the prediction. With that prediction, we test if the first value is 0, then we say that the message is a ham, otherwise the message is a spam. And here is where things get interesting. So what you're doing here is to render template. This render template is going to call this home HTML, these attributes, which is the concatenation of this message. This is a, and the placeholder here is going to take the value of the label information that we have at the end of the process. And finally, we run the Flask application with the debug, a throw, the local host, the default route, and we run it on the port 9696. And let's move to the home file. In the home file, there are some specific information that you have to consider. First of all, we have the static folder, which contains, the design of the user interface, this HTML file, and you have to create a folder called templates. In the templates file is the home HTML. You can give whatever name you want, but that name has to match the exact same name here. If you call it index, then you have to call this one index as well. And in the home file, what we are doing here is to trigger the action first. So the URL for is the action of the form is going to call the predict function. So this predict function is the one that we have here. So this is the predict function that we are going to call. And in the predict function, we have the final result, which is the prediction. Here, the concatenation of the personalized message. So this is the final message that is going to be shown. this is error, and the final result is either ham or spam. Okay, and this variable is the exact same variable that we put here in the HTML file, surrounded by double brackets on both sides. If you write prediction, let's say we had written prediction here, and here we'll have exact same name, prediction. It's just a matter of consistency. Make sure that you have the exact variable names on both sides. Now that we have this, I think there are a couple of libraries that we need to install as well. We have to install scikit-learn. But remember, when we were creating this, we were training this model, we didn't create a virtual environment before. Let's say that we want to run Python, the application. So this is going to break because we don't have a scikit-learn library installed. A good way of fixing this, because I want to know the exact version of the libraries that has been used to create the model. So let's deactivate that virtual environment first. Deactivate the virtual environment, and now we can, and also let's say that I want to exit right after showing the versions, because I don't want to run again the same, the same codes below. And now what we can do is run Python train. This is going to show the versions of the libraries that we have installed here. So with this version, we can finally activate. So add source, the name is docker vm bin activate. We have the virtual environment activated, and now we install pipenv install. So we're going to install scikit-learn. The version that we are using is 0.24.2, and also we install joblib. I think we have already installed joblib, so no need of installing joblib again. And now we can install it, scikit-learn. All right, this is going to install the exact version of scikit-learn that has been used to train the model, and now we can finally remove this one. And after installing scikit-learn, it might take a couple of seconds, depending sometimes on the speed of your internet connection, but it might not take longer anymore. All right, so if you check once again your pip file, you'll see that the scikit-learn has been installed, and the exact version scikit-learn 0.242 has been installed. All right, with this scikit-learn, now we can finally run the Flask application with Python app, because the app.py is the file containing the Flask application. So we give that file name and we run. If everything goes well, we should have the URL to access the application. All right, make sure to copy the first one, which is a local host, and let's paste it into a new browser to see how things go. So this is the application that we have implemented. Now let's say that you as a user provide this message and you want to know if this is a spam or a ham. And the message says, hello, this is a message to inform you that you have won the DV lottery. And let's run to see what it looks like. Well, the prediction is a ham. All right, congratulations, you have created your Flask application. You are almost halfway of getting done with this tutorial. And the next step, I'll explain how to deploy that. Well, now that we have created the Flask application, the next step is to create the corresponding Docker image. So this starts by creating a file called dockerfile. We're going to create this on the Docker folder. So the name is dockerfile. And in this Docker file, there are some information that need to be provided. And the first one is the Python version that we're going to use. And to make sure that we're using the correct Python version, we're going to check it here. So Python version. Okay, now we're using the Python 3.9 version. And to make sure to run the application with the same Python container, we are going to say from Python 3.9. And since this is a light application, we're going to use the slim version of Python 3.9. And now we need to set up the working directory. So the working directory is going to be the the name that we want to give. So it's going to be work the slash application. Okay. Now what we need to do is to install pipenv, because pipenv is the library that is required to install all the libraries. So this is done with the run command, pip install pip environment. Okay, so this is going to run the installation of the pip environment. So the next step now, what we need to do is to copy the dependency files. We start to copy all the information required to run the application. We have the dependency file, the model, the vector, and these also the template folder and also the static folder. Let's start with the copy of the pip file and the piplog file, because these information are all required to run the application. This is done with the copy command, the source and the destination. So the source is, now we're going to give the list of the pip file, which is this file here. We are also going to copy the pip file .log. And where are we going to save this on the current working directory? We also need to copy the application file, which is the app.py. So copy the app.py here. We also need to copy the models, which is the models folder, into the models folder. This models folder is the destination, and this destination is going to be created if it does not exist. And also we need to copy vectors to a vectors. Vectors is the .vector folder that we have here, and it's going to be copied to a new folder called vectors, and this new folder is going to be created. Also copy statics into a static, and copy, what else do we need to copy? Templates into templates. And what else do we need? And I think we have copied everything. And now the next step is to run, to install everything, all the information that we have here. So now we run pipenv install deploy system. So this is going to run the deployment of the Dockerfile and all the dependencies. All right, now we need to specify the port that we want the application to run in. And if you remember, we are running the application in the port 9696. So we need to expose this port so that it can run on the container. So what we need to do is to expose the port, which is 9696. And finally, we run the application, which is running this command. The command to run the application, remember, is Python app.py, and this is the exact command that we need to run. It takes in parameter, all the information like Python and app.py. So this is going to run the command Python app, the exact same command that we have here. All right, so we're done with the Docker file. This is the overall structure of the Docker file. Well, we have the Docker file. Now we need to build the image based on that Docker file. This is done using the Docker command, docker build .t. Now we specify the name of our application. Let's say that the name of the Docker image is spam spam classifier classifier app, right? And we need to specify also the version. Let's say that this is the latest version .f, and we specify the path to the Docker file that we want to build. And this Docker file is located on the Docker folder, and we specify docker/dockerfile, and we want to start building here. And now we run the building process of the Docker image. This might take a couple of time to build on the Docker image. This process has done a couple of steps, 12 main steps. So you can see here, it's copied. It's basically executed all the steps that we have specified in the Docker file, setting up the working directory, running the pip install, copying the file, running the final command here. Now that we have built the Docker image, now what we can do is to run this Docker image. So this is done using the docker run.it.p. Now we need to specify the inbounding and outbounding port 9696, which is the inbounding, and the outbounding is 9696, the exact same port that we are using. And after that, we .rm, the name of the application, which is spam classifier app.latest. The reason why we are using --rm is to destroy, the container once we are done with using it. You can remove this one if you don't want to destroy your container after you run the application. And with this, we can execute. And executing this is going to set up the Docker container. So this URL is the exact same URL that we had before, but this time it's running in a Docker container. So let's get a new window. Okay, so let's run this application to see how things are gonna work. All right, so we have the same message and run the prediction. Finally, we have the prediction. Congratulations, you finally managed to build your machine learning model, creating a Flask application and deploy it. Create a Docker image for that machine learning model. In a next video, I will explain how you can deploy that Docker container on a cloud platform like Azure using Kubernetes. If you like this video, give it a thumbs up, and also let me know in the comment section some other ideas or different topics that you want me to cover in my future videos. Thank you. See you next time, and bye bye.